Okay, perfect. So I'm Martin Carrier. I'll be the presenter here today for SmartTrek. So before we start, maybe a little bit about myself. So I grew up in the countryside on a farm when I was young. I studied mechanical engineering at Laval University, where I graduated in 2008. This was just before I took over the family business. Back then, the family business was in the Christmas trees and maple syrup production, which is not the typical farm, but yeah. Then in 2011, I started SmartTrek with two partners. And from 2018, I stopped being fully involved in the family business of the maple syrup production to fully concentrate myself on SmartTrek. I'm also a father of four, ranging from 13 years old to 8 years old. The first time I got involved in groundwater dewatering was in the end of 2016, beginning of 2017. Before that time, I had absolutely no idea what was dewatering and what it was about, how it was done. So it's still not so it's still somewhat fresh to me, but I'm starting to understand it a lot more. So yeah, today I'll present to you a little bit what SmartTrek do and one of our case study, one of the biggest project we did in groundwater dewatering and construction site, which was for the Eglinton Crosstown light transit rail transport in Toronto in Canada. So just a little overview of the presentation. So start with who we are, the product and services we are offering at SmartTrek, why monitoring is important for the dewatering industry. We'll talk also about how SpiroMesh technology works. So SpiroMesh is kind of the radio technologies that we've designed in the beginning that allows us to do what we do today. I'll talk a lot about SmartTrek HVAC system, which is the monitoring system, because SmartTrek has multiple type of products, and HVAC is just one of the things we do. And then I'll talk a little bit more in depth about the case study in Toronto. So at SmartTrek, we provide easy connectivity in challenging environments. So what we want to do really is to connect objects and machines, no matter where those objects and machines are installed. What it means, it means that no matter where you have data point to collect, is it underground inside a tunnel, is it in a remote area where connectivity is difficult, or is it even in urban canyons right in the middle of a city? Basically, anywhere where typically connectivity is difficult, it's where we really shine and where we can connect these objects better than anybody else on the market. So SmartTrek journey started in 2011 when we first wanted to create a monitoring system for the maple syrup production. So maple syrup production is something that is typically done in a remote area where connectivity is difficult. We have to cover multiple square kilometers to be able to connect subjects together. When we looked at what was in the market back then to connect objects in remote area like forests, like these difficult environments, there was nothing that could fit the requirements we had set for ourselves. So it's where we started to look at what was done in research, what could be done to improve the performance of the radio technology to better create a system that would work in these environments. And it's where we started the development of SpiroMesh. So what was supposed to take about 2 months, 2-3 months to integrate the radio module with pressure transducer to basically collect the vacuum level in the middle of nowhere, basically took us 2 years. So we commercialized our first product in 2013, 2014, the real production, and then everything started from there. Now SmartTrek count 13 employees in our ranks, half of them which are engineers, coder, programmers, and we are basically building IoT connectivity solution for multiple different markets. We're all very passionate about what we're doing about the wireless connectivity, IoT, and also all the applications that goes with it. So we're learning every day new things in pretty much any aspect of the company. So about the product and services that we are offering, so you can see here like a little tree with three main branches. The first one is the HVAC monitoring system, which is exactly what we offer to the market for the dewatering industry. Basically, it's a plug and play, ready to use monitoring system that can collect any kind of data such as water flow, water pressure, vacuums, and stuff like this. Then we have a second branch, which is the wireless radio modules. So we offer the SpireMesh radio technology that I've talked about earlier, that we designed initially to solve some challenges in maple syrup production monitoring systems. So we have a radio module with our radio technology on board that we sell to other manufacturers that can use this radio technology to connect their objects as well. And then we also do electronic design, and always basically around the core of SmartTruck, which is the SpireMesh radio technology. So for example, a good example of electronic design, we have a company here in Quebec that produce snow hydrant for ski mountains to make snow. And we did a whole electronic design with the radio module and the connectivity on board to replace the PLC they were using and do the monitoring and the control of those snow hydrants directly in the mountains, which was a big challenge for them because connectivity is not always evident in those environments. And then what they did before using our products and our new design was to literally wire them all. So they would put wires inside the communication wires inside the mountains, which is not always evident, which and can always fail at some point. In the product and services, again, that we are offering, those would be more packaged solution. So for example, in the water and municipal water, wastewater sector, we offer district meter, the area flow meter, pressure and flows to help find leaks in water distribution system. Still in the same market, we offer a sewer level monitoring system with rainfall and basically to measure the inflow and infiltration in the sewers and detect overflows, report overflows to authorities, which is another big package that we are offering. We're offering package in construction dewatering, of course, to monitor the water levels in the ground, the pressure, the flows. We also have package for bypass, so monitoring the equipment that's gonna be used for bypass and also controlling these equipments. We also have another revenue stream, another part of our HVAC system that is indoor air quality. I won't spend too much time on this, but basically we installed, our equipment has been installed in 1,400 schools, 30,000 classrooms in Quebec, where we monitor the air quality, the CO2 level inside the classroom, and so the government can assess what to do to improve the air quality, if what they're doing works, and try to help the kids learn better. So what we think at SmartTruck is required for a good monitoring system, and basically these were the main objective we wanted to achieve when we created SpireMesh. So I think the first and foremost point is the quality of service. Anyone using a monitoring system needs to have reliable data, no matter where their equipments are installed. They need to know that it's going to work. They need to know that they can make it work. Second biggest point we thought was low maintenance. We wanted to have something that would operate by itself for multiple years without being too cumbersome. So it's why we opted for a battery. We wanted to achieve something that was very low powered, so we could be battery operated on the device themselves. We think also, and this is maybe not so much in the watering industry, but we wanted to be able to cover great distances with our system. So no matter if all you need to monitor is close by, or if it's really spread out, you still want to have a reliable monitoring system that is low maintenance, and that's going to work even if you have to cover a great distance. Of course, security, which is I think very important in most of our applications. We also think that those systems need to be flexible. So by flexible, I mean, if you want to add sensor, if you want to remove, modify the locations of the sensor in the field, it should be easily done. It should not be something cumbersome where you need to send a technician to try to modify just simple things like changing a node location, a sensor location. It needs to also be scalable, meaning you need to be able to go from 2 devices to 10 to 100 to 200 easily and affordable. This is another, I think, very important point. Any monitoring system needs to be somewhat affordable, so it actually brings value. It's not something that will just cost more, but also bring the value. And I think all of these points are all in the same line of thought, that it can bring simplicity in the data management and the monitoring aspect of things. Simplicity is very important. When we first started SmarTrack in the maple syrup industry, the average maple syrup producer was 58 to 60 years old with absolutely no technical background. So we wanted to make a system that even a person without that technical background could install and maintain and use its system while bringing value to them. So simplicity is a very important aspect in monitoring system. So how SpireMesh works? So how our radio technology work, and why is it better in difficult environments? So basically, SpireMesh is what we call a mesh network. So if you take, for example, and I'm sure most of you guys already are used to cell network technologies where you put a SIM card in a flow meter, for example, and it will send the data to the cloud. But sometimes that flow meter is going to be installed at the bottom of the pit where maybe the cell network coverage won't be so good, because cell is point to point. So if you can't have direct access to the cell tower, then it just won't work. You're going to need to reposition the device to a place where it's going to have a coverage with the cell. And this is not always simple. When you're above ground, typically you can always find a way around it. But when you're on construction site and sometimes at the bottom of a pit, it's not going to be that obvious. A mesh network technology, how it works is that all the devices, and it's a little bit what we show here in the picture, is all the devices will talk with their peers to send the data back to the gateway, which is the access point, and then push the data to the cloud. So that way you can always be certain that the connectivity will reach anywhere you need it to go. If there's a gap in the connectivity, you add a repeater and it's going to extend the network by itself. So even if you're right down at the bottom of the pit, you put a repeater right on the side of the wall, and then it's going to relay the data from that device to the gateway. There's no topography, or environment that we cannot solve with a mesh technology like SpireMesh. A couple other advantages. Typically, mesh technologies are not good for battery consumption. It's where SpireMesh step really aside from those technologies. Typically, on the scale, we're going to have about 10 to 30 times less power consumption than the typical mesh radios. So it's why now we can use a mesh technology that will have about the same or similar power consumption than the point-to-point radios, and much more or less than any cell radios anyway. The system can be used to either do monitoring and control. So it's a bi-directional radio technology where the data can go both ways. And once basically a customer installed the Spire Mesh system, it's going to be a private network. So you're not relying on other third-party provider where you need a SIM card and pay some monthly fees on each devices you have in the field. It's just going to be basically your network, and it's going to be free to operate. And because it's mesh, well, it's very easily to scale. It's easily to add sensor. It's easily to extend the range and go fetch more data points that can be a little bit farther on your network. Of course, as I said, the protocol is really secure. And this is a little bit how it works if you want to understand a bit better in the field. So we have the data that the nodes, so each communicating points in the network where we collect data as well is what we call typically a node. So each node is going to talk together to send the data to a gateway. The gateway then either by Wi-Fi or by Ethernet will send the data to the cloud. And from the cloud, you can access the data from anywhere in the world. So that's it. So a little bit more about groundwater dewatering. And I know this will not be new to you guys, but just to make sure we're all understand ourselves from the beginning. So dewatering typically is going to involve machinery running on sites for multiple months. Typically, you won't always have personnel. I know in the past it used to be a little bit more like this, but typically you won't have somebody on site 24/7. So the sites are remote. Each visit to those sites can be costly. It might be 2 hours on a pickup truck with 2 guys. So it's not typically the kind of things contractors want to do, right? Sending people to sites where they're going to go there just to make sure everything is running fine can be very costly. Then most of the customer typically will want to be also informed on how the equipment is performing. Is the dewatering effective? Is it respecting the contract they have with the contractors? Are they getting what they're paying for? Stuff like this. Then often the customer will request reports on the job that has been done. A lot of dewatering is done in urban area, so it must comply with the city regulations, the environmental regulations, and it's also another place where it's not always easy to move trucks to. And also one thing that we noticed, most of the time, contractors will already using monitoring system when they're looking at SmartTrack stuff, but typically they'll have multiple systems. So they're gonna have the generators or the diesel pump on one system. They'll have the flow meters on another system, pressure maybe in another system as well. So they have to navigate through multiple dashboards, multiple interface to validate what's happening in the field. So then why it's important to monitor, of course, we've been a little bit through that, but basically, I think the most reason why you should all do monitoring, remote monitoring, is to save money. Sending a team on a job just to do some routine verification, as I said, can be very costly. So it's not the kind of things you want to do. And you definitely don't want to get on the site on a Monday morning realizing that the pump has stopped, and then you get there and the site is flooded. it's not the kind of thing that is fun to start the week with. And also, you don't necessarily, when you understand what's happening on the site, maybe there's a little problem, but you don't necessarily want to send someone on site. So for example, if you have a vacuum pump on a well point system that is typically running around 20 inches of mercury, well, if it drops to 15 inches of mercury, maybe you know that there's an issue, but the dewatering will still be effective. So maybe you don't want to send a team right away on the Friday night, but maybe the team is already scheduled to go next Wednesday, and then you just go the next Wednesday, figure out what happened, and fixing the things. If basically the pump totally fails, then maybe the team's going to go just right away on the Friday night. So it's important, in my opinion, also to really keep track of what the work has been done on the ground, keep some kind of proof of work. So if your customer asks for if there's an event and the customer blames you, then you always have proof, let's say that the water table were always below some level, and that even if, I don't know, what pump stopped, then it didn't affect really the construction site or the environment where you're doing the watering in. And also, same thing about the regulations, environmental regulations or city regulations, where basically you always keep track and you can always get proof to the authority bodies that basically everything has been done in the correct order. So the watering concern, we've been on that already. So how at SmartCheck we adjust these challenges for the dewatering industry? Well, first of all, with our equipment, you can really get 24/7 monitoring of pretty much any kind of data point or fields that you want to monitor on the field. One of our strengths is that we have over 35 types of sensor that can be used for various parameters, no matter it's pressure point, vacuum point, flows, some water quality probes, rain gauge, stuff like this. We have those, and we can help with those data. So instead, with all those different sensors, instead of having to manage your operations on multiple platforms, it's all going to be recouped under a single dashboard where you have all your different device types, all your different sites that are running at the same time, right there at the glimpse of an eye, where you really see everything super easily. We also provide an alarm system that can send alarm to multiple recipient groups. Whenever an equipment runs outside its normal parameters, for example, it can send email, it can send SMS or calls. The calls are with text to speech, basically, where someone's going to directly read to you the error that's happening. So if you have if we take the example before of a well point system with a vacuum pump, supposed to be running at 20, then it will call you in the middle of the night saying, oh, the vacuum pump X is running below 20 inches of mercury. So it's kind of super easy to understand what's happening in the site, and you can log in your platform. Basically, this system, this alarm system, how it works, it's with multiple groups. So you can have an 8 to 5 group, and then after hour group, a weekend group, and also a group that is more as a, how do you say that, basically a critical group for when nobody answers. So the system will start by contacting the primary group in the normal time. Then if nobody answers, it's going to switch from one group to another until someone acknowledges the error. So you can have a tree there that is going to be followed if an alarm is happening and nobody answers. Then you can snooze the alarms, deactivate, reactivate the alarms. It's very simple to use. And I think it's something that is a very high value in your industries, where you have those equipment running all the time on remote locations and nobody to really look at them live. But then if something happens, the people that needs to get a warning will get that warning and will know what to do with it. Then we also have basically a nice interface with graphs, with live data, where you can really see all the what's happening in the field. You can adjust your parameter on the fly. You can use also this application to add sensor, remove sensor, change sensor from one site to another. You have the full history on each of the nodes or sensor that are installed in the field. There's also in that dashboard a nice feature with child account. So basically, if you have a primary account owner, that person can add other accounts to the same dashboards with less feature or less permission to those other accounts. So you can have an employee, for example, that's just going to be able to add nodes, remove nodes, but not change the alarms. Or you can have a portal for your customer that's going to log in, but your customer won't have any capability in changing the parameters of the system. It's going to be just a read-only permission, for example. So this can help to give more value also to the system by helping your customer to really see what's happening in the field. Did I miss something here? Yeah, and you can also generate reports on some sensor, on multiple sensor. With our dashboard and our server, you can also send the data to other platforms. So if you're used to use a specific web application or dashboard from another third party, then you can just bring the data from our system to that other platform. In that case, it would be more easier for you since you're familiar with that other platform. That I think we've went through. And I would love to add that basically we have a lot more functionalities in the web application that I don't want to go one by one of all these features. I think it would just bore everyone to death. But maybe one last feature that I'd like to introduce to you is the block programming section we have in our application, where basically we can automate almost anything. So for example, if a tank reaches a specific level, then open a valve and start a pump, stuff like this. So we can really do automation in the field, on the fly, easily. And if you don't have the capability, of course, Smartrick is always there to help to build those automation so that you guys can have these features available in the field and do whatever you need to do. A good example of these automation block, about a year ago, we did, basically we didn't, but we built the system to do the bypass on the water treatment plant for the water supply line. And the contractor had 4 diesel pump that was pumping water in the pump house of the municipality, the city. Basically, there was 2 6-inch, 1 8-inch, and I think 1 10-inch pump. And depending on the level of the well of the pump house, basically it would start 1, 2, 3, or 4 pumps, and it will just automatically always keep the level at the same point inside the pump house. The system ran for I think 8 or 9 weeks last year, and it was a very good demonstration of what this remote control system with the automation could do for the industry. So what we can do, I think I've been a little bit about all of this already, but basically we can measure any tank aquifer level in the well, so well levels, vacuum levels for vacuum pumps, water temperature, pump status, pump runtime, water flow, water quality, anything related with water, really, we can help. Then let's get to the case study. So basically the case study is the construction of the light rail transport of the new Eglinton line in Toronto, which was at the time the biggest infrastructure investment made in Ontario, in Canada, the whole Ontario story. So the Eglinton Crosstown line is a 19-kilometer corridor, including about 10 kilometers of underground portion, with roughly, I think it's 25 stations. So for the one who knows, Toronto is a city that is built on a sandy soil. I think everyone knows that sandy soil can be sometimes tricky for dewatering if the watering is not done correctly. In 2015, when the work started in Toronto, basically there was a contractor team that didn't do an adequate dewatering. And when they were digging the tunnel, they hit a water pocket, and during the night, the water infiltrated inside the tunnel, which resulted in, I think it's roughly 50 meters of sand that was drained inside the tunnel, and the street on top collapsed. The construction site has to be closed for about a month, and during the period of which they made sure that the soil integrity was still fine, that it would not be a problem for both the street and the construction of the tunnel below ground. And it basically gave them a lot of a full month of a delay in the construction, which was not super nice for them. So after that, the city of Toronto asked for 24/7 monitoring of the aquifer level in the ground to make sure that the work of the dewatering company would be always adequate to the construction. And it's where basically one of the contractor get in touch with SmartTrack to start monitoring the aquifer level, the vacuums, pressure. Basically, it was in 2017, if I remember correctly. So what we've done is, so monitoring vacuum sensor on the pumping line to make sure that the vacuum was always present, that the vacuum distribution also was good on the line. We also installed current sensor that were placed at each electrical panels to make sure that the amps that were being pulled out from those panels were always in the normal parameters. So if a pump stops, and then, well, if you typically always have roughly between 40 and 50 amps of current that is pulled at a specific panel, and then it goes out of those parameters, then you know there's something wrong. Either a pump pulls too much, or there's a pump that is not working. Then we installed flow meter to keep track of all the water that was being removed from the work that was being done on the ground. We also installed temperature during the winter to make sure that the line wouldn't freeze, which in the end, we realized that it was not necessary to do that. So, but in the beginning, it was just an uncertainty. Maybe the line will freeze, so just make sure it doesn't. We also installed the water level at multiple points on the line where the construction was happening. At peak, I think we had more than 250 SmartTrack sensor deployed on the Eglinton Crosstown. One of the particularity of the system is that we were monitoring both inside the shafts and overground, and basically the system would all be on the same network. So we would use the ventilation shaft just to get the data out of the tunnel back to the gateway, which was installed at the surface. So when talking about being able to collect data in very difficult environments, that would be the kind of thing that is mostly impossible with most. If you go see wireless specialists, they all will tell you that this is probably impossible, but we did it with SpireMesh and our technology. And basically the data that was collected on the line was being analyzed daily by the worker on site, by the engineer at the office in Toronto, and also by other specialists around the world, in UK and in US, that would tap inside the data and do some further analysis on these data. And basically, the system was used with SmartTrack dashboard, but also with other two other dashboards. One for the city of Toronto, that was where they were always getting the data live, and another platform that was more targeted towards tunneling for the tunnel experts. So a lot of reports were generated from these data, and I hope that this helped the construction and keep the delay at as minimal as possible, and the contractor to do a better job. Maybe I can also add that if you have any questions regarding the case study we did in Toronto or any other project we did in the groundwater dewatering, and we were not aware of all of them because we don't necessarily have always the information from our customers, but feel free to contact me. It's going to be a pleasure to explain and also to help if you have questions about, and this is the kind of thing that happens sometimes. Basically, everyone are not necessarily at the same level on these things and these remote monitoring stuff. So we have customers that will call us and that have absolutely all the knowledge that where we can't not bring much more than just the equipment, but we also have other customers that are fairly new, that doesn't know exactly what sensor to use for let's say measuring the aquifer levels and how to use that data to actually something that is beneficial, or how it can help them also to just monitor their various equipment, what piece of equipment they can monitor that will give them some values. Basically, we're here to help. It's going to be a pleasure to answer any question regarding the type of monitoring, the why and how to do it.
Excellent, thanks, Martin.